Hi, today I'm going to go through chapter 4, the introductory chapter for explaining linear regression in the online textbook Introduction to Econometrics with R, which is an accompaniment to the textbook Introduction to Econometrics by Stock and Watson. So I'm just going to go through the R code that they have in this chapter slowly in a separate script, and I will share that script with you. You can cut and paste the script from the code that they provide here in the chapter, but it's sometimes easier to start with a script that already has everything cut and pasted, and I have a little bit more annotation in my script. So you'll want to download that script, open it with our Studio, and then run the commands following along with this video. So I encourage you to pause the video right now, download the script, open our Studio, and then be ready to go. So the the Econometrics with R book is here is the website address for the book. You have a link to it, hopefully, and you can see that chapter 4 is linear regression with one regressor. So pretty straightforward. We're estimating the slope of a line and the intercept that best fits an XY scatter plot, a scatter plot of two variables, an X variable and a Y variable. The example that Stock and Watson and Econometrics with R uses throughout is having the student-teacher ratio be the variable on the x-axis and the test scores in the school district be the variable on the y-axis. The idea that a small student-teacher ratio, few students per teacher, would lead to more learning and higher test scores. So a larger student-teacher ratio, lots of students per teacher, would lead to lower test scores. So we would expect that we'd estimate a negative slope, a negative beta 1 coefficient in our regression. So we'll see whether that holds true with the data set that is supplied in a package in R called the AER package. That's the California Schools data set that's used in the textbook. There's multiple ways to get this data. We'll load it here from the package. There is, of course, an online version that can be directly downloaded from the Stock and Watson website. The two data sets are slightly different, but not in any material way or important way that affects any of the outcomes. We'll come to that one in a little bit later. Okay, so let's go on to linear regression with one variable. I am just going to scroll down here, and we see right here we have the two library commands that will load two packages, AER and MASS, and we'll need to install those packages beforehand. I'm going to just do one more page here in the the online textbook, and then I'll jump over to the script. So here we have some code. We're creating sample data, sort of fake data of the student-teacher ratio and the test score. So we just create two vectors, and then we'll estimate the regression with those two vectors, or create a line and see whether it fits. So let's go over to our Studio and do that. So here we are in our Studio, and this is the script that we'll be using for our Studio. So it's called Intro Econometrics Chapter 4 Basic Regression. We're not going to use all of these packages, but for some of the other scripts we'll be using them. So I have the install packages command here, and you'll copy this and substitute in any of these packages that you don't have already. And we're going to be using 6 packages for these couple of scripts that we'll do looking at chapters 4 and 5 in the Intro to Econometrics. So here's our library command that loads the package when we're in the R session. So I'm going to go ahead and run these commands. So I've already installed the packages. So we run the commands, and since I've already installed them and I've actually already loaded them earlier, you see in my command script, something that often happens is you highlight something and run it, and then you accidentally delete it, something to be very aware of. So down here in my console, I don't get any response. when I load these again because they're already loaded. So now I'm going to click my cursor on this line 17 and hit Control Enter on Windows, Command Enter, Command Return on a Mac, and I create a variable called str. It's just a vector here, and then I create another variable called test score. So again, it's just a vector, and then I'm going to use the simplest kind of built-in plotting function in R to plot these dots. And you see that we can plot student-teacher ratio on the x-axis, and so we have student-teacher ratio on the x-axis and test score on the y-axis. And here's 1, 2, 3, there's 6, 7 observations there. Each dot, right, is a pair, x and y, a student-teacher ratio, and a test score. Now, if I wanted to fit a line to these dots, one thing that I could do is create a line myself that has an intercept 713 and a slope. And so let's add this line. So we use the command AB line. So we're just going to draw this line. So I hit Command Enter, and there's a line. And it looks like it fits reasonably well, but this line, 723, let's run that one. So that line also looks like it fits reasonably well, and maybe let's make the slope a little steeper. That line, let's make it even steeper. That line. So we see we have many, many lines that could fit this data. And our problem in linear regression is to find values for the intercept and slope that describe the best fitting line. So we'll minimize the sum of squared residuals. So the command to do that in R is called LM, linear model. So we'll run that here with this little sample data, and we see that the best fitting line is close to the line that they proposed, 713.568 minus, and the slope is 2.968. So that's the best fitting line to the third decimal. Of course, we could do another line to the 10th decimal if we liked, and that would be even better fitting, right? So it's always a matter of degree to it, the approximation that we are comfortable with. In economics and much of the social sciences, we rarely are interested in approximation to any high degree. So second decimal is a convention that we just report two decimals for anything that we're estimating. Of course, it all depends on the scale, right, of the variables. So let's go to the actual data then. But before we do that, let me show you that the LM command displays the coefficients. We have the summary command, which we can also use, and that will display more statistics related to this linear regression. And in particular, we'll display the standard errors. So here are the standard errors, the t-statistic and the p-value. And then down here, the r-square and something that we'll call the adjusted r-square that we'll come to later, and also something called the f-statistic and its associated p-value. So we'll be explaining what all of these statistics mean as we go through the course. For now, we'll just ignore them. But note that the summary command is a command that we might use. And then another way we might display regression results is using the stargazer command. To do that, we're first going to save the regression results in an object called reg1. So that reg1 is now over here. We can see it. It looks like gobbledygook when we click on it. So we want to display that. So we're going to display it using the stargazer command. So stargazer reg1, we're going to have it be text, so it just shows up in our console, and we'll call it a regression model. So we run that, and we got a nice little table. Regression results are often displayed this way as columns, where the column is the result of one regression. So we have our coefficient on the student-teacher ratio and our intercept, 713. Notice we also have asterisks here, which are going to indicate the degree of statistical significance of our hypothesis test. Below, in the table automatically is reported the The 3 asterisks means that the p-value is less than 0.01. Again, we're going to come to that in chapter 5. So now let's go ahead and unload the actual data. So the actual data is called California Schools, and we see California Schools now in our environment. It's from the AER package, in this case, 420 observations. This version of the data set doesn't have the student-teacher ratio and the test scores in it. We need to calculate those and create new variables. So we're going to create new variables in the California Schools data set. So the convention is data set name, $, variable name. So we have student-teacher ratio preceded by California Schools, $, and then it's going to be the students divided by the teachers. So we run that. We have a new variable. We run that. The next one, which will be an average score of the reading and the math scores. So the reading score plus the math score divided by 2 is going to be our new score. And we can plot this data. So using the simple plot command. And that's what our data looks like. Our student-teacher ratio is there on the x-axis and our test score on the y-axis, and we have 420 observations. We would like to know what the best fitting line is for this data. So we'll use ordinary least squares. We can compute these by hand in the formula, right? So we can use the formula that beta 1 is the sum of x minus x times y minus y bar, x minus x bar times y minus y bar divided by the sum of x minus x bar squared. So that's what we've done here. And we calculate beta 1. And notice that beta 1 then appears over here. And if we want to see let's calculate beta 0 hat, which is y bar minus beta 1 hat times x bar. So beta 0 hat is there. And if we want to see them in the console, we just click down here. So the slope is negative 2.28 and the intercept is 699 to some degree of approximation, right? So those are our estimated slopes. Let's verify with the regression command that that's what we get, 699 and negative 2.28 indeed. Let's also call this linear model and then do the summary of the linear model or the stargazer of the linear model. You see that the stargazer is a lot cleaner display of the regression information. So we'll always be using the stargazer command instead of the summary command, because the stargazer command will also let us display multiple regressions in a single table. Let's go ahead and plot the data again. So there's the data again, and add the regression line. Notice we say add line linear model. And now there's another way to do it, which is the way we'll always be doing it in this course, which is to use the ggplot2 package, which is has command ggplot. So we tell ggplot that the aesthetic, the AES, is x being student-teacher ratio, y being the score, scatter plot g on point, and then we'll have the smooth regression line method linear model. And so let's run that, and we give it a title, and it computes the little shaded region here. We'll talk about that in the next chapter. So that's all the R commands. So it gives you an idea of how linear regression works in RStudio and some idea in the intuition of it. You can go ahead and change variables, change data, and especially here where they have their little small data set, you could add some values to that and see how that changes the regression coefficient if you like. I'd encourage you to do that to give you a more intuitive understanding of regression analysis.